Welcome to Going Offworld, your gateway to the cosmos beyond our Earth. Join us as we embark on this journey together to the Moon, Mars, Venus, and beyond.
Welcome to episode 4 of Going Offworld. I'm your host, Steve Fisher. Today, we're diving deep into the future of space exploration with Dr. Geoffrey Landis, NASA researcher at the John Glenn Research Center, who's spent his entire career developing technologies that will help humanity explore the solar system and beyond. From innovative Mars missions and solar-powered spacecraft to wind-sailing vehicles, Dr. Landis shares fascinating insights about how we can use local resources to sustain ourselves in space. As both a NASA scientist and acclaimed science fiction author, he offers a unique perspective on turning science fiction concepts into reality. Whether you're curious about nuclear propulsion in space, or how we'll power future missions, or even what it's like to operate on Mars time, you will not want to miss this conversation about the technologies that will transform space exploration. Join us on this journey where the sky is not the limit and the stars are just the beginning. Welcome, Geoff. Nice to have you on.
Okay.
So, as I always start the podcast, you and I have had a couple of conversations and gotten to know each other. But for those who don't know you, could you kind of share your background and talk about what inspired you to pursue the career in science? I would love to hear that.
Sure. Let me talk a little bit about myself.
Sure. Great.
I'm Geoffrey Landis. Right now, I'm a researcher at the John Glenn Research Center in Cleveland, Ohio. We don't launch space missions. Nobody calls home and says, Cleveland, we have a problem. We develop technology for future missions, both for aircraft and for space. So I've spent most of my career looking at technologies for space and what we can do with future space missions. With that said, I have been fascinated by science and technology, and specifically by spaceflight, ever since I can remember. Part of it is I've been a science fiction reader all my life. So science fiction has been giving us a vision of a future world in which we can do wonderful things. It gives us a view of the planets as more than just little dots in the sky, but places that we can go, places we can find out about. It gives us a view of the universe as a huge and marvelous place. So that's been part of it. But part of it is I just love learning about the world, learning about science, learning about how things work, and how you can make things.
That's great. And I know that you've been working on a number of planetary projects. Let's kind of move to let's talk about Mars first. So the exploration robotics, the Geyser Hopper and Hero.
Mm-hmm.
You've worked on some really amazing projects. Could you kind of share about what those were and how they change could change our understanding of Mars?
Yeah, of course. Mars has been a subject of fascinating research in both science and, of course, in science fiction for years. And we've been looking at the question, what can we do on Mars? I've spent a lot of my career actually looking at solar power on Mars. And most of the missions that we have to Mars up until the Curiosity and Perseverance rovers have been solar powered. I was part of the Mars Pathfinder and also the Mars Exploration Rover missions, mostly looking at the solar energy. But then back in the technology development, we've been looking at what can we do in future missions to Mars. One of the keys that we're discovering to moving out into the solar system has been how can we use the resources of space? So in human flight, at least, up until now, we go into space and we bring with us everything that we need. But clearly, if we're going to move out into the solar system with settlements, with humans, ultimately we're going to have to use the stuff that we can find in space. We can't bring everything from Earth all of the time. It's kind of the difference between going out on a camping trip or going out to settle and live somewhere.
So I want to talk about, sorry, go ahead.
No, go ahead.
Yes.
Go ahead.
So that refers to the in-situ, I don't know, pronouncing it correctly, resource utilization, the ISRU. So how would that be implemented? How could that be implemented on Mars too? Because you're right, it has a lot of impact, I believe, on missions.
Yeah. One of the interesting conceptual breakthroughs about Mars is that the resource which is easily available everywhere on the planet is the atmosphere. So sometime in the 1980s, people really focused on the atmosphere as the next breakthrough in how we can make things for future missions. Now, it turns out for spaceflight, what you really, really need most of is propellant. You think, humans need oxygen, humans need water, humans need food. That's all true, but all of that is sort of secondary to the fact that you need huge amounts of rocket propellant. So the in-situ resource utilization has focused on how do we make rocket propellant on other places. And in Mars, we looked at Mars and said, well, it's a carbon dioxide atmosphere, and there's two interesting things people proposed for Mars. The first was they discovered that, in fact, it's relatively straightforward technologically to just break one of the oxygen atoms off of a carbon dioxide molecule, and you can then get oxygen. And that's an electrolysis process that's pretty similar to what you've probably done in your high school chemistry class, where you put a couple of electrodes in water and make hydrogen and oxygen. It's the same thing, except you're making carbon monoxide and oxygen. Now, mostly people have been focused on, oxygen is the most important component of rocket fuel, so we can make the oxygen on Mars. One of the researchers I worked with at NASA Glenn looked at this and said, hey, wait a second, we're also making carbon monoxide. Turns out carbon monoxide can burn. It's a flammable gas. It's a little bit hard to ignite. It takes a little higher temperature to ignite. But once you ignite it, you can make a carbon monoxide oxygen rocket engine. So with that technique, you can make both the fuel and the oxidizer for a rocket. Now, the alternative technique people have been looking at has been saying, if we just have a source of hydrogen, we can make methane and oxygen. That's a better rocket propellant, but hydrogen's a little bit harder to get on Mars. You either bring it from Earth, which is hard, or you could drill into the soil and probably get some water and electrolyze the water. But that's a little bit more complicated. Now we're talking about a lot of earth-moving equipment, drills, and things. On a large scale, that's obviously what you'd do. But on a smaller scale, it's a little bit more complex. So we looked into what can we do with a carbon monoxide oxygen rocket engine. And we said, one thing we might want to do is fly around. So we could make the fuel on Mars, fly around, and refuel ourselves from the atmosphere with a rocket-powered hopper. Of course, I guess I have to say, now the people with the helicopters have sort of beat us to that goal of flying around on Mars. But at the time, it was quite a bit before the helicopter had been invented. So we were, or at least before the Mars helicopter had been invented. So we were looking at a rocket-powered hopper.
I played with a Mars simulator using scramjet technology. Because of the lighter atmosphere, you can move fast. So it is like very little moving parts, scramjet, glider, basically, that you could move around and do all types of construction, movement of equipment. I mean, there's a lot you can do with it. You hold, and you mentioned solar earlier, you hold a lot of patents, several patents related to photovoltaic tech. Yeah. Do you see that, like, in terms of step with in-situ, like, would you power 3D printing machine? Would you power machines to create all those, like you said, the Mirth movie? You'd have to make the things there, right? You'd have to, but you have to get it's kind of chicken and egg, right? You have to get the materials to make the things, then get the materials to make more things. So what advancements are exciting you about this side, that side of it, and solar power and what it can do? Because, with the probes, I know you've worked, you said you've worked on many of the Mars rovers. What excites you?
Well, power, of course, is the key to everything.
Yeah.
You can't really do anything in space without a power source. And I'm a great fan of appropriate technology. Use the technology that's appropriate for the mission. So any place where sunlight is available, if you got the sun, you really want to use solar power.
Yeah.
Solar cells are lightweight and cheap and a reliable source of power. And so the vast majority of things sent into space are solar powered. That's mostly just because the vast majority of things sent into space are pretty close to the Earth. Once you go into the far outer solar system, where there's not much sunlight, nuclear power systems look better. Interestingly, if you're on the moon and you want to operate in the dark, nuclear systems are looking good as well, because the moon has a 14-day nighttime. And it's awfully hard to operate on batteries for 14 days. Not impossible, but hard.
If I had a Tesla, I live in Boston. I couldn't even drive in Vermont. Yep. So, it's...
Well, yeah.
And then where would I plug in? Yeah.
Yeah. Well, and you get sunlight at least once every 24 hours.
Exactly, right. I think, talking about the rover, did it surprise the team when, I believe it was Pathfinder, right, that kept going? Like its end of life was, because the solar, the winds on the would just kind of clean it off. And did it surprise the team how long it went? Was there something that was just like mind blowing, like revealing? Yeah, please, if anything, share.
Yeah, the Spirit rover in particular surprised everybody. Yeah. Our initial calculations back before we had good data suggested that the dust would be sticky enough that the Martian winds would not blow it off. But turns out on Spirit, once we got to the summer and had the windstorms come by, and particularly the dust devils, the very first day we saw dust devils, we also saw the power jump up on those solar arrays, and that was something we hadn't expected. It really helped the mission along. That we got a little bit of help from Mars. Mars liked us.
That's excellent. Well, what other probes or exploration do you think should be done in parallel to prepare for the manned mission that's eventually, I don't want to say eventually, but hopefully will happen within the next decade,
Well, I am still a huge advocate of in-situ resource utilization, that we really have to start going into space and using the stuff we can find there and stop bringing everything from Earth. That has not been a major focus of actual missions, but there's a lot of work going on in various little corners of NASA on trying to develop that technology for space resource utilization. We did a study, actually, of looking at can we do the Mars sample return mission by making the oxygen for a system on Mars, and it looked pretty good. Eventually, they didn't pick that. Of the 6 options that we came up with, that wasn't the one they chose, mostly because they were saying, well, this is an undeveloped technology, and any technology that isn't flight ready has some risk to it, that maybe it won't work as well as we think. But my real push for NASA would be, let's get places and start using the things that we can find there. We've done a lot of work at looking at in-situ resources. We've looked at Mars, of course, lot of people now talking about the moon. But there's also Venus. We're looking at ISRU on Venus. We're looking at in-situ resources on Titan. We think we could fly a return mission to Titan. And that's now we're talking a billion miles away. But we think we could make our fuel on Titan and bring a sample back. So really, power systems that can operate and in-situ resource utilization are really the key. Once we have that, we could really open up the solar system.
You provided me a great segue because I was about to move a little closer to Earth and talk about Venus. So one of your, I think, incredibly innovative projects is a wind-propelled rover for Venus exploration. What are the challenges that Venus presents compared to Mars? And there's some basics, obviously, because of the heat, but what are some unique challenges?
Yeah, Venus and Mars are interesting because other than the fact that the atmosphere is carbon dioxide, they're sort of opposite in every possible way. Venus, the atmosphere is way too thick. It has an atmospheric pressure that's equivalent to the pressure a kilometer under the ocean. And of course, that 450 degree Celsius temperature is actually a real killer temperature. It's really hard to make things operate. But despite that, NASA Glenn has been working on electronics that operate at that 450 degree C. And we've solved a lot of those problems. We can make electronics. We can't make everything, but we can make some things. So looking at that, well, in fact, when I was studying Venus, the very first thing I was studying was solar-powered airplanes for Venus. That was back when the NASA administrator was proposing, well, why don't we fly an airplane on Mars for celebrating the 100th anniversary of the Wright brothers? And in response to that, I was a little bit working on Mars airplanes, but looking at it, I was saying, wait, why Mars? The really nice place to fly would be Venus. If we can get above the clouds, the weather's nice, the temperature's good, and there's plenty of solar energy. So I did a bit of work on solar-powered airplanes on Venus. That work never took off. Sorry, no pun intended there. But nobody really said, oh, that's just what we need in the world is a solar-powered airplane for Venus. Although I'm still a big advocate of that. But then we started looking at Venus and saying, well, can't we get down to the surface? Let's see what we can do on the surface of Venus.
Is that where land sailing comes into play?
Yes. So the problem with the surface of Venus is at 450 C, solar cells don't work as well as they do at room temperature. And that thick atmosphere cuts down the amount of sunlight reaching the surface by a lot. So you're not getting very much power on the surface of Venus. So we said, well, we can make electronics that operates. We can make solar cells that operate on Venus, but you don't get very much power. You get a couple of watts of power, not the hundreds of watts that you might need to drive across the surface. So we said, well, how can we use the resources we have on Venus? What do we have on Venus? What we have is a thick atmosphere. So the thinking on the wind sailor for Venus was, let's drive using that wind. And it turns out people have done that on Earth. Both actually hundreds of years ago, they made wind-powered wagons that crossed the plains. And more recently, some people make basically sort of sailing vessels that sail across the deserts. And we said, well, we have a thick atmosphere. Let's make a sail-powered rover. So now we don't need to provide power to drive. We can drive just by sailing across the surface. Looks like a good idea. We're still working on some of the technologies that would support doing that. So it's not something that we're quite ready to do. We still need some of those high temperature technologies, but it still looks good. It looks like something we could do, and I think that would be actually a really cool mission. Basically, like a sailing vessel for the plains of Venus.
I would I'd love to pilot that, and I imagine someone piloting that would be in an orbital platform, or
you could pilot it from an orbital platform. You could put basically all of the brains in orbit. So the sophisticated computers and stuff would be in orbit, and then just the simple electronics would be on the surface of Venus.
Earlier guest of ours, Guillermo Online, which is how we connected. He's obviously working on his Venus nonprofit initiative, and Earth to Venus. And he talked about the livable layer for humans.
Yep.
And I mean, have you worked on any of the atmospheric platforms in that way? Are you familiar? Could you speak to that?
Yeah. I was several years ago, I presented a paper at the STAFE conference sort of proposing that you could make cities in the atmosphere of Venus. Of course, like Earth, as you go higher up in the atmosphere, it gets cooler. And at that level, about 55, maybe 58 kilometers above the surface, think of it as about 30 miles up, you get to that Earth-like conditions where the temperature is close to room temperature, depending on how high you are. And the atmospheric pressure is actually a little bit below Earth normal sea level pressure, but not bad. Of course, the atmosphere is still carbon dioxide, so you still do have to live in a bubble that has an oxygen or an oxygen-nitrogen atmosphere. But that's easy.
You can walk outside with a very thin suit and just the mask, right? You don't have to have a full...
Right. You don't need a pressure suit. You just need to protect yourself from the environment. That's above the thick sulfuric acid clouds, but there's probably still some pretty corrosive things in the atmosphere, even above the thick clouds. You're sort of above the thick middle cloud layer, but below the thinner upper cloud layers. So you'd want a suit that's not going to be corroded by the atmosphere. But you don't have to live in a pressurized suit, which is, as we've discovered, very bulky and hard to deal with.
Yeah, it's not exact parallels, but it does remind me of Antarctica. Like the elements
in
there
some
will
ways,
kill you.
Yeah.
That's like you have. It's not corrosive, but it's definitely hypothermic and deadly, and you have to be ready for that environment and kind of do live in a bubble a bit, like McMurdo. But so with all of these opportunities and like the in-situ, like the research utilization that would happen, make it where you live, make it where you are, right? Actually, is this the kind of the tagline? What do you think is and we've been sending out these probes and we're trying to get the manned missions up. Obviously, SpaceX is doing their thing and NASA's doing their thing. What do you think is the next major milestone in exploration?
Well, the NASA program is all about going to the moon and then from the moon moving on to Mars. And I think I certainly hope that we keep up momentum on that because it's good to have a destination.
Because not only just preparing as a base to build and launch from there, but having a permanent settlement, like going back. We haven't been back since the 70s.
Yeah.
And, it's funny. I collect a lot of space memorabilia. And when you look at the program and, you look at the evolution from Mercury to Apollo and Skylab, and it's an era that seems foreign to a lot of people because a lot of the kids they just don't know that we went there 50 years ago, but to go back and now just establish something, it's going to be very interesting geopolitically because the moon doesn't belong to anyone from the
Indeed.
I mean, when you watch shows like excuse me, when you watch shows like, I'm blanking, I'll have to put this back in later. It's the alternate history show.
For All Mankind.
Thank you. When you watch shows like For All Mankind, when you're there, it becomes territorial. It's one thing to go there and explore and we're all together in Kumbaya, but it starts to actually produce resources like Helium-3 or become bases. It's going to be very interesting and I think a contested challenge for geopolitically, but that's my take on it. But you think that next milestone is just getting us back as a manned crew, just humans back on the moon and just making it a useful, regular thing. I completely agree with you because it becomes the base for all the things we want to do.
We have to start somewhere, and I think the moon is a good place to start because it's so close. It's a 3-day trip and not a 6-month or a 9-month trip. So, but I'm just hoping that we don't stop there. This is just the first waypoint in a longer journey.
Well, it leads to the question of what you said. We can make some things, we can do some things. Geoff, like, what do you think in technological advancement will be most transformative in the next few decades? What's going to support that? You talked about nuclear power, ships. There's fusion, which is happening. There's a lot happening. What do you think is the most, would be the most transformative for us in the next few decades, realistically?
Well, the transformation that we're seeing right now that's very exciting is reusable spaceships. We tried to do that back in the 1980s with the space shuttle, but it turned out it was perhaps a step too far to have a winged vehicle going into space, try to reuse everything and try to do that all without taking any risk. But now there's sort of the second attempt to make reusable spaceships, and that will, if we get it right, be very, very much a transformation in the cost of getting to orbit. Once we get to orbit, I would really love to see some advanced propulsion systems starting being used. Chemical propulsion is great, but once you try to get high delta V missions, high velocity missions, you really, really would like something a bit more energetic. What is sort of looking good would be nuclear propulsion. There's sort of a long time been sort of a fear of anything nuclear, but we have to get beyond that. Space is the place for using nuclear energy, nuclear thermal for high thrust propulsion, nuclear power plants to energize electric propulsion systems for long-term exploration. So I'm really excited that is back on the table. People are now talking about some very high energy, high efficiency ways of moving through space. I'd love to see a nuclear electric system go out to explore the outer planets, go past Jupiter and looking at Saturn, looking at Uranus and Neptune. Once we get these nuclear electric propulsion ships, the solar system gets a lot easier to get to.
Yeah, and the system that comes to my mind is the Orion project from the 60s, Freeman Dyson,
Yes.
dropping nuclear bombs down the throat to increase speed. But I think the fear there was that if it took off and it exploded, it would destroy a large swath. I think it comes down to where do they make the engine, right? If you have an orbital platform above the moon, or you have, it's almost like, why I was thinking about things like if you do something outside of the house, you don't want to endanger where you are, the livability of it, right? I think having those labs set up to build those, I think that's where it will take hold more so. Like if you have all the components, you can take the uranium, you can take everything up and then put it together, and then it doesn't have the risk is reduced. I think you're right. Once they have the ships and the propulsion systems are going, I'm a big propulsion person. I think that's, if I really got into being a scientist, that's probably what I would have studied. But that's definitely, it's the key, right? To got to get around.
The bomb-powered spacecraft certainly was a wild idea and sort of looks interesting. It's a little bit more, I think, beloved by science fiction writers than by people who look at the actual difficulties of doing that sort of thing. The current ideas for nuclear thermal rockets are more evolutions of the old NERVA rockets, Rover and NERVA and things, where the interesting thing about those nuclear propulsion is that they're not actually radioactive until you turn them on. So when you launch them, it's just uranium. You're launching essentially chunks of uranium. So they don't start reacting. You don't get the nuclear reaction until you turn them on, and there's what we call a nuclear safe orbit. And that's the idea that you don't want to turn it on until it's high enough above the Earth that it won't re-enter naturally for thousands of years. So even if something goes wrong, even if it does the equivalent of a meltdown, well, it's okay. It's there's something orbiting the Earth, but it won't come down and won't threaten anybody on the ground.
You are a great segue person. You're great at doing segues because you talked about the science fiction element of it. So you are the other half of you is you are a science fiction author. They were well known. How did you get into writing science fiction? I know you've read it, you're passionate about it, and you've read it since you were a child.
Yeah.
I share that with you. How did you get into writing?
Well, I was, of course, reading science fiction ever since I was young. And then actually when I entered graduate school, I thought, well, I got to give something back. I've taken so much enjoyment out of all the stories that I've read. Well, why don't I try writing some? And I was lucky enough that the things that I wrote seemed to be the sort of thing that the editors and the public liked. So I kept on writing. It was fun. It's a different way of playing with ideas. So it's parallel to, but not identical to actually doing science.
So there's the book you wrote, Mars Crossing, won the Nebula and the Hugo. Tell us more about that book.
I have to say it was nominated, but did not win. It did win the Locus Award for first novel. So it was considered the best first novel, but not the best novel of the year.
That's a heck of a novel.
I wrote that one after the Pathfinder mission. I spent a lot of time on the Pathfinder mission just working with the sort of essentially living on Mars. We were actually living on Mars time during the Pathfinder mission. And so I was just sort of saturated with Mars, and it really gives you the idea. Wow.
Tell me about Mars time. What is that? What does it mean to live on Mars time and on Earth?
Oh, sure. Yeah. Mars is remarkable in that it has a day that's almost the same as the Earth day. It's the only planet that rotates in just about 24 hours. But it's not exactly 24 hours. It's 24 hours and I think 39 and a half minutes. So since we were operating a solar-powered spacecraft on Mars, it wakes up with sunrise and goes to sleep with sunset. So the science team that's operating it also has to live on the same schedule as the spacecraft. So we're living on a day that's 24 hours and 40 minutes long. So that means actually, interestingly, that when you get up at Mars time and go to bed at Mars time, you drift through Earth time at about 40 minutes a day.
That's what I was going to ask you. Basically,
40 minutes later.
You drift. So
yes.
How did that work? Did like half of the team work to a certain, and then at least get their circadian back, and then the other team would kind of take over? Because you can't to try and keep up, you would lose. There would be a major effect on your brain chemistry and your ability to sleep.
Well, actually, what they did is the first thing they did is in all of the science areas running the spacecraft, they blacked out all the windows. So when you're actually in the areas that we did planning for the mission, you don't know whether it's dark or light outside. It's we drifted through time every day, getting up 40 minutes later. Actually, I loved it. I thought 40 minutes per day is all I ever wanted. Another 40 minutes to get everything done.
That's pretty fun. That's
but
good.
I was actually, of course, from Cleveland and living in Pasadena where they were running the mission. But so I was nevertheless, I didn't have friends and family and a support system there. The engineers that actually lived in Pasadena kind of hated it because they were out of sync with their family, out of sync with their children, etc. So they eventually convinced us, okay, we've been running on Mars time for a month or two. Let's switch back to Earth time and just plan things further in advance. So, but I thought it was great. I loved having an extra 40 minutes a day. That was
cool.
Great.
So tell me about the story of Mars Crossing. What's the book about?
Well, I wanted to write a book sort of showing the diversity and sort of how big Mars is. So it was a story about a mission to Mars. And this is, in fact, not the first mission to Mars. It's hoping to be the first successful mission to Mars.
Oh.
And I put my characters in a situation where they actually have to go across Mars. In fact, pretty much going from equator to pole of Mars.
Did they land in the wrong place? Did they land?
Well, in the story, they landed in a place, but their return spaceship wasn't working for sort of silly reasons. But they needed to find a place where there was a working spacecraft. And in the background of the story, there was a Brazilian mission to Mars earlier that failed after landing on Mars, but had a working spaceship. But it was up at the polar cap of Mars. It was not at the equator or near the equator where the next mission to Mars landed. So they have to get from the near equatorial regions of Mars all the way up to the equator to find a spaceship that is actually working.
So I wonder, when did this publish? When did you put this out? When did this come out, in the 90s?
I think the first edition came out in 99.
Okay.
And then the paperback came out a couple of years later, and then the book club edition. So
I keep wondering if Andy Weir was inspired by your, go to another ship to get off the planet. And it just reminds me of, that element of that book, which is an excellent book on its own. So
yes, indeed.
But it's a fascinating story because, you by de facto, you're one thing to be an explorer to land on Mars and have a successful mission. Now you're truly exploring the planet because you have to make the journey. Right. Yes, you have to explore. You have to explore, not just take some samples and get on, and go back home. That's the themes like survival, human ingenuity, future. But what are the themes you find most compelling to explore? I'm sure it's all of them, but is there something that really, above all, really that you just drives you in your writing?
Well, to a large extent, what drives me is just the thinking about, we're going to be going out there. We're going to have troubles. We're going to have both human and natural troubles, and we have to learn to solve our problems. We need to find out what's there, what we can use, what the what the resources are that would allow us to solve our problems.
That's great. So what would you give as advice to aspiring science fiction writers, me included, who want to incorporate scientific realism? That's the big, that's the key, like yours and like Andy's. There's that accuracy in it, which I think adds an element of not only respect for the novel. When you watch shows like The Expanse, right? It's there's a certain the plausible reality of this thing where it's really not that far. So how do you incorporate that in your story?
Well, I think the main advice I give to people is write what you're passionate about.
Yes.
So if you're passionate about, who knows what, improvements in biology and what future biology might be like, improvements in spaceflight, and if you're passionate about whatever, climate change, write whatever fascinates you. And then when you're writing what fascinates you, you're probably going to be doing the research anyway that will be influencing your writing. If you're fascinated about other planets, you're probably, watching with fascination all of the mission results. You're saying, okay, here's the mission to asteroid Bennu. Wow, what are we learning about Bennu? What will we be learning about asteroid Psyche? And what that does is it makes the research fun. You really want to make it accurate because it's what you're fascinated about. If you were fascinated, I don't know, about France, you would hate writing a book that really isn't true to the reality of France. So, when you write what you're fascinated about, you will do the research and you'll find it fun.
Well said. That's a great advice. So I'd love to shift to kind of more long-term stuff. So like with your research, what are your long-term goals with your career? Like what are you hoping to accomplish in the years that you're continuing to work? Like what do you hope to do with the research?
What I'm really hoping comes out of the research that we're doing is flying better technologies in space. What we can do in space is always limited by what we can do technologically. So I really would like to bring more advanced technologies into the realm where, yes, we have it, it works, we can fly it, and it will give us more capabilities. That's sort of what we do at a technology center. The other thing that I've been doing a lot of is looking at what new and different types of missions can we do. We talk about sort of the next generation mission, what's next, but what's beyond that? What can we do as we go further and further into the future? So I've been sort of looking at everything from Mercury missions to near-sun missions, all the way to interstellar. Where can we go? What are our limits, and how do we expand those limits? How do we make better technologies?
That leads to the question I usually would ask in terms of the long-term future. What do you as you think deeply about this a lot, what do you envision? How would you envision the future of human space settlement? Let's say 50 to 100 years from now, because all playing out. What would that span look? What would that look like in that end state? Would we be interstellar? Would we be interplanetary? Like, just put your futures.
I think 50 years is a little bit ambitious to be interstellar. I really do think that should be our long-term goal, but there's a lot of technology development. I would love to see humans permanently in space in 50 years. Mm-hmm. The question that everybody has to deal with, and it's a really tough question, is what can humans do in space that robots can't? And that is a hard question. At the moment, the answer is humans are much more versatile. Humans are much better. I remember in the Pathfinder mission, there was a press conference at the very end of the mission, and Matt Golombek, who was the principal investigator, the lead scientist for the mission, one of the reporters asked him, well, that was an 80-day mission, and the 80 days that Pathfinder was exploring Mars, how long would it have taken a human geologist to do the same mission? And Matt sort of looked off into the distance for about 2 seconds and said, about an afternoon. So humans are tremendously more capable of robots. But the problem is the robots are getting better.
Yes.
Every year the robots are getting better and better, and the humans aren't. So in 50 years, we're going to have tremendously capable robots. So the question we all have to answer is, what do the humans do? Why do we need the humans in space? And I don't know if I have an answer to that, other than the answer that wherever we explore, humans should go there too. Having the robots do the exploration is like having your friend go on vacation and send you postcards. That's fine, but that's not the same as going there.
Yeah, I look at it as an exploration partner. Like, you use AI now to help you give you ideas. You don't just use it or just you think you're going to outsource the task. But if there are things that are a little more dangerous, but it needs the guidance of a robot. It needs the help. Like if it's going to do mining work, the risk, you can mitigate a lot of risks for the human component, but the human should still be there. Right. So I look at, part of me as a futurist, I always want to look at possible futures. And one is this, I would think in the next decade is we're going to see a technological, not akin to the .com era, like a bubble, it could be a bubble, but a personal robot revolution, because you see all these companies starting to build them, and then they're starting to incorporate the Gen AI systems. And as those things start to kind of evolve and really get mature, I mean, yeah, it'd be great. I don't really want a robot making pasta for me, but if it's, if it helps my mother who's, by herself, and it's as a care robot, right? There are a lot of aspects to the companionship of that, and then the assistance of that. And there's obviously the ethics of, labor and all that, but we won't have to get into that in this podcast. But it's a great point you make. You talked about some of the things of, you think about interstellar, you think about interplanetary. What is a futuristic innovation to become reality? What would that be? I think I know, but if you could have something come in your lifetime, what would it be to come to pass that you've wanted to exist?
Oh, there's so many different things that could transform
you gotta just
our
pick
life.
one. Yeah, exactly.
You have to pick through a large banquet, much of which is explored in science fiction. If we were really going to go interstellar, what we need is a much more advanced propulsion system. And that would be far beyond the nuclear rockets I was talking about earlier. People have been talking about... the Alcubierre drive would be an interesting thing. I don't really believe that one. I'm sort of very skeptical about it, although some recent results have suggested that you can do a slower than light Alcubierre drive and not violate the principle of requiring exotic matter.
So and essentially, like the Star Trek, Trek's the sublight, the impulse drive in the starship, under lights.
Yeah, they haven't really explained the impulse drive in Star Trek.
That's what I think. I think it's just but, nuclear, some sort of propulsion. I thought it would be something for the an efficient nuclear drive you would might pick, but when you think about your growing up reading science fiction and just everything you've kind of taken in as a researcher, can you think of one book that's profoundly influenced your thinking about things in the future, like how you approach your work, like just what's really been an influence for you?
Wow, of course, there's so many influences. That's another one that it's hard to pick a single work. I think the books of kind of Heinlein and Arthur C. Clarke back when I was a kid, not necessarily even the ones that you remember, but the ones that are just talking about what would it be like to live in a spacefaring civilization. Things like perhaps Heinlein's The Rolling Stones, or some of Clarke's novels, even things like A Fall of Moon Dust, or Prelude to Mars. Just talk about, okay, we will be living in space, and these are the things that we'll have to deal with. Of course, back then they had a very optimistic view of how Earth-like the other planets would be, and so I think we're not going to be looking at swamp monsters in the swamps of Venus, unfortunately.
So, with that in the past, giving you in that motivation, what continues to inspire you, like to push the boundaries in exploration?
Just all of the possibilities that are out there inspire me. Every day we're learning more about extrasolar planets, for example, and also learning more about the planets in our solar system, things that, partly with missions, partly with the outgoing missions to the asteroids, a lot of interesting asteroid missions, looking at things like the Juno mission to Jupiter, and of course the upcoming European mission to Jupiter, and then, for that matter, the launch of the Europa Clipper, hopefully in the next month or so. There's so much exciting things we're learning. It's just fascinating to keep up with it.
That's great. Well, if people are fascinated from this conversation, as we wrap up here, like, how do people stay updated with your work? How do they can check out your research, your science fiction? Where's the best place to connect with, to find you online and connect with you?
Yeah, I do have to admit that I am terrible at keeping up with my website. I just don't keep updating my website. But you can look at my website, geoffreylandis.com. It's easy to remember if you know how to spell my name. But otherwise, just looking at, I have hundreds of scientific papers online. You can do a Google search, or of course, look at my Wikipedia page, which I don't update, but turns out other people every now and then do update it and show what I'm up to. And
it's great.
Lots of papers, and of course the occasional science fiction story as well.
It's great. Well, I want to thank you for being on the show today, and just thank you for sharing your wisdom, your research, and all you're doing. And just, it's great as we, continue to go, explore and get out there. So thanks for being on, Doctor.
Okay. Well, it's been fun. Thank you.